Hello, in this final video in week 3 we're going to be looking at piecewise defined functions in section 2.4. What is a piecewise defined function? Well, that's a function that has that it is hard to define with one rule. So what we have is we have a multiple of rules given different domain elements. So if we have something that works in part of the domain, but then something else works in a different set of domain elements, then we define them in pieces so that the function has more than one piece. In this case, this first example is a cellular phone plan that starts out at $39.99 for any time up to 450 minutes. So if your minutes here, that's your X domain values, are between 0 and 450, it's going to cost you $39.99. After that, there's a different charge. There's additional charges per minute. So there's a second rule or function that's used to define this piece of this function. So we have anything that's greater than 450, we use a different rule to define what the values are. Okay, so a piecewise function can have multiple different rules depending on what the domain is. So in this case, we're just looking for some values out of this piecewise function. So when we have so many minutes, we're going to define them in a different way. So anything between 0 and 450 in our domain here, from 0 to 450, we're going to have that value. So that means looking at this one's going to be in that range. These are not, they're bigger, so they're going to use the other part of the function. So in this case, my answer for 200 is going to be $39.99 because that's 200 minutes is less than 450. It's between 0 and 450, so we're going to use that rule. Now the other two values that we're asking for in this cellular phone is 465 and 451. Both of those happen to be bigger than 450. So we're going to use this rule for that. And this is the X value, so we're going to plug that in. We're going to have 0.45 times 465 minus 162.51. And if we do that, that's going to give us our value. So let's see what that is. 0.45 times 465 minus 162.51. So that's going to be $46.74. So in this case, $46.74 is our answer to this one. Okay, and our last one, we're going to do the same thing, but we're going to plug in 451. So in this value, we're going to have 0.45 times 451 minus 162.51, $162.51. So if we figure that out on our calculator, here we go, clear 0.45 times 451 minus 162.51, we get $40.44. So that would be the value here, $40.44 for one extra minute. We're going to pay about 50 cents. It's 40 some cents there, 45 cents for one extra minute. So that's what a piecewise, and this is an example of a piecewise function. So in our next example here, we're going to evaluate, this one doesn't give us, this gives us some pieces, but it doesn't tell us the application that relates to it. So we have a piecewise function here, and we're going to evaluate these pieces. So what we want to do is determine where this value is, which domain is -2 in. So is it greater than -1, is it equal to -1, or is it less than -1? So in this case it's going to be in this domain, so we're going to use this rule for the first problem. So we're going to write -3 times our -2 value that came from our function. -2 goes in the function, so the answer to this is 6. Alright, so we get 6 here for this one. Alright, -1. So -1 happens to be in this, so -1 happens to be equal to -1, so we're going to use this value. Well, there's nowhere to plug in our value for x. It's a constant value, so our answer here is 0. It's the constant 0 value there. It doesn't have anywhere to plug it in, but that's our function that we're going to use. And 0, for our third value, 0 is going to be in this domain. It's going to be greater than -1, so we're going to use this rule for the third value here. So we're going to have 2 times 0 squared plus 1. So that's going to be 2. Oh, sorry, that's not correct. That is going to be 1. I don't know what I was thinking there. It is going to be 1, because this part is 0 plus 1 is 1. So our answer is 1 there. So that's evaluating. If they didn't give you an application, this one we had an application. We evaluated them based upon the application. This one just gave us 3 rules with 3 different domains. We had to determine which domain to use and which rule to use from determining where our values, our function values, our input values, which input value did they go in. Okay, now in this one we're going to graph. So when I graph a function, usually what I do is I look at my domain. So my thing is to look at the domain here and determine where I'm going to cut my values off. So in this case, my values are going to change at -2. So I'm going to have right here at -2, I'm going to have a break in my graph. So this says I'm going to graph less than -2. So for me, that means I usually just put a dotted line there down this line so that I know part of my graph. This is not part of my graph. The dotted line is not part of my graph. But this is telling me that I'm going to graph everything on this side for this value. So I can put some values in there and figure out what they are. Now, I need to know where my line, exactly where it starts. So I'm going to put in -2 to the graph. So I'm going to take this. I need to know where it starts. So I'm going to pick an XY chart. I'm going to start with -2, even though it's not in the domain. I'm going to go -3 and -4 because those are less than -2. So I'm going to graph on this side. I just need a few values. So at this point, my open circle, where the graph is going to end up, is going to be at 1. So I should have an open circle here at 1. Right there at 1, I should have an open circle, because it's not included in the domain, not in the domain. But I needed it to know where we would start our graph. Our open circle starts there. And then I put in -3, that's going to be 0. And put in -4, that's going to be -1. So my graph goes to here and to here. So it looks like it's going to be a straight line going this way. And it goes forever this direction. Okay, so that's my line that goes this way. Now on my second part of the graph, I'm going to start with another, I'm going to start at -2, but I'm going to increase. So I'm going to make myself another chart here, an XY chart, or an f of x. I'm going to start at -2 again, but I'm going to increase my values. -1, 0. Okay, I know that this is linear. It has a slope and an intercept. So if I start at -2 and I put that in there, so -2 times -2 is 4, minus 3 is 1. So my first value is at 1, and that is in the domain because it says equals there. So I'm going to start at 2, 1, which is right where it ends here. It's going to fill that circle in. And then negative 1 in there gives you positive 2 minus 3, so that's going to be negative 1. And then 0 is going to be 0 minus 3, so negative 3. So we're going to take our line and go to, it's going to go like this. Keep going this direction. So it's going to be like that. Now this is actually a continuous graph because if we filled in the whole, both values, the one that's not in one side and the one they matched up, so this is going to be a continuous graph. So this graph is going to be continuous. Okay, our domain, since we're going less than negative 2 and greater than or equal to negative 2, our domain is all real numbers. Is all real numbers. Our intercepts are going to be negative, so our intercept here is going to be negative 1.50. Our intercept here is going to be negative 30. And our intercept here is going to be negative 3. Okay. It's continuous, and we want to give the range. The range is the values of y that come out of this. So our range is going to be y, or f of x, is going to be less than or equal to 1. That's our range. Okay. My last example is how to write this as a piecewise graph. So in this case we have two pieces. So I'm going to have two different pieces here. And I like to start off with the domain. So if I look at this piece, it's going to have a domain from here to here, so that's going to be negative 1 to 0. So negative 1 to 0. I'd write that this way. Less than or equal to, negative 1 is less than or equal to x, less than or equal to 0. And this one here starts at 0, but it's not including it. And it goes to positive 2. So, and it includes positive 2. So that's going to be my domain. And I usually start with that by looking at where they're cut off at. Now this one is a nice one because it's flat. A flat line is a constant. And this one is always 1. So this is just going to be 1 in this rule. Now this one over here is a straight line. So when we look at the straight line, we want to get the slope of this line and the intercept. Well, what's nice is they gave us the intercept. Here it is. It's 0. So in the slope here we can just count rise over run, so the slope is 1. So in this piece I'm looking for mx plus b, y equals mx plus b, because it's a straight line. That's what I'm looking for. In this case b is 0, so we can leave it out. B is 0 because of this 0 right here. And then slope here is rise over run, which is in this case 1. So my answer here is going to be 1x. And my y is this value, so there's where the y is, and the y equals mx plus b. It's f of x. So this is my piecewise function for that value.